Well, here we are starting stoichiometry. So at this point, we have been looking at a lot of things in terms of just isolating our equations for the mole. So n is equal to n on Na when we're looking for the number of particles being converted into moles. So that's converting a number of atoms into mole or a number of molecules into a mole of molecules. And we've also looked at n is equal to m on mr, where we've got the mass of a substance and we want to find the number of mole. So now we get to really start to put that into practice, combine it with some balanced equations and see where all this is leading and hopefully clear up some of that confusion. So let's get started. So stoichiometry is essentially a fancy word that chemists use for basically calculations that they do to work out quantities. Okay, so it's nothing really other than calculations in chemistry. So for that, we're going to need to use the mole. Okay, this allows us to work out what we need to use for chemical reactions. So transferring that number of atoms into a amount of substance in grams. So far we've learnt the equations for finding the moles of a substance, okay, and we do have more to come, okay, and we know how to have balanced equations. So stoichiometry is basically putting that all together. If we follow the rules, much like we did with percentage composition, it makes it much easier to follow the logic and see how he's going. So the first thing we do is write a balanced equation. We can't do anything in terms of stoichiometry without writing a balanced equation. Okay, then we write the known and required information. We get that from our question. Determine if the reactant is in excess, and that's coming soon, so not yet for us. Okay, and then determine the mole rate relationship. So this is our ratio that we're going to be talking about. And then use the appropriate equation to solve the problem. So we're doing mass at the moment. So most of these are going to be some variation on our n is equal to m on mr equation. So I'm not going to spend a lot of time going through theory. The easiest way to get your head around these is by actually doing calculations, okay? So I'll show you a couple of different ways to do this. Really, it comes down to how you feel most comfortable doing the maths, and we can talk about different ways to approach this in class as well. But let's have a look. So we've got a question here, and it says that a piece of copper wire has a mass of 2.25 grams. There's a couple of things that I'm going to realise with this. One being that copper wire, I should be starting to think Cu solid. Okay, this one's going to give us the equation, but these are things to help you thinking about it as you go along. I've got a mass of 2.5 grams, so that's going to be an m in my equation, and we're told it completely dissolves in a solution of silver nitrate. And then we're given the balanced, and we're told it's balanced equation for the metal displacement reaction. So we can see that copper solid is with 2 silver nitrate goes to copper nitrate and silver solid. And then the question is asking us what mass of copper 2 nitrate will be produced. So this is mass of copper 2 nitrate, so we're talking about this species here, okay, and what mass of crystals of pure silver will be produced in the process. Okay, if you think about this, we want to find the mass of copper nitrate. Okay, so what we're after, sorry, that keeps zooming up. Let's put that back into place. What we're after here is the mass of this one, okay? But we don't know the mass of that substance. What we know is the mass of copper. So we need to work out a relationship between these two things here. So let's have a look at how we can do that. So let's start with copper. We've got a mass, and we know that we can figure out the molar mass of copper because we can get that from our periodic table. Okay, so if we pull up a periodic table, which I'm just doing here, okay, we can get the molar mass of copper, which will be around 63 from memory, 63.5. So we know MR of copper is 63.55 grams per mole. Okay, and we've been told that we have M of copper is equal to 2.25 grams. Okay, so what we can do here is the first things first. If you think about this, we can find N. So N of copper is going to be equal to 2.25 divided by 63.55. Okay, so 2.25 divided by 63.55 is going to be equal to 0.0354 mole. Okay, and you may be wondering, okay, well that tells me how much copper I've got, but how is that going to inform me about the copper nitrate at all? So this is where the coefficients of our reactions come in. Okay, so we should remember that even though it's not there, these coefficients for each one of these is 1, which means that for every copper that reacts, I'll form copper nitrate. So this is a 1:1 ratio. So that should mean that for N of copper that reacts, I will produce the same number of mole of copper nitrate. Okay, so this is a 1:1 ratio, so we can see that quite obviously. Okay, now there is one way that we can do this that always works, even if it's not 1:1. Okay, so if we think about it, copper is my known substance because all the information that I need was given to me in the question about copper. Copper nitrate is my unknown. It's what I'm looking to find out about. It's what I want to know about. Okay, now anytime I want to step from one point in a chemical reaction to another point in a chemical reaction, I need to use what we call the mole ratio. Okay, so as long as I can find a number of mole, which we've already done for copper, I can step across my reaction and basically work out any other point in my reaction as long as I have that mole ratio. I determine that mole ratio by using a formula where I say I multiply by a factor of what I want over what I know. Okay, and what that means is I look at the coefficient of what I want, which is my unknown, and that goes on top, and I divide it by the coefficient of what I know, which is in this case my copper, and I multiply N of what I know by that. Okay, so in this case, it's 1/1, so it's going to be multiplied by 1. So I'm going to be able to say that my N of copper nitrate is going to be equal to 0.0354 mole because it will be the same. Okay, so now if I want to work out the mass of that, I'm just going to use the mass is going to be equal to N times MR, where the N is 0.0354 mole, and then that will give me a number of grams, which I will let you work out for yourself. Here's the thing, it's not always 1/1, but I can use this relationship regardless of what I'm going to do. So let's have a look. The next question asked me to find the amount of silver that will be produced. Okay, so now I'm not interested in copper nitrate. So we're going to make that go away. But I'm interested in what my unknown is now, or what I want, is silver. I can still step down by a mole, across by my mole ratio, and up by my formula to silver. Okay, in this case, I need a new ratio, and 1:1 isn't going to work. But if I apply this theory, I can multiply by a factor of what I want, which is now 2, this one here, by what I know, 1, and that means I'm going to multiply my number of mole of copper by 2. So N of silver is going to be equal to 2/1 times N of copper, because that's the one that I know, which is going to be 2 times 0.0354. Okay, which is going to put me with a number of mole of 0.0708 mole. Okay, this is mole. So now to step up, back up to what I want to know, I'm going to use my mass is equal to N times mR, and I'm going to multiply that number of mole by my molar mass of silver, which is 107.8. So the mass of silver is going to be equal to the number of mole, which is 0.0708, multiplied by 107.8, which is the molar mass. And that will tell me that we will produce, multiplied by 107.8, we're going to produce 7.63 grams of silver when this reaction occurs. Okay, so it doesn't matter what we know or what we want, we can always work out a way to get there. Okay, I'm going to go through some other example questions. I suggest you pause as you need to go. This will go for a little while, but let's look at some examples. The best way to do this is practice it. If you think you have it, have a go and see how you go. In the next one, I'm going to use a slightly different method rather than this what you want, what you know. Okay, so have a go, make sure you practice it, and if you need a little bit more clarification, come back and watch another example. Okay, this is number 2. In number 2, we're looking at potassium chlorate reacting to form potassium chloride and 3 lots of oxygen. Okay, and it asks us how many grams of potassium chloride are produced if 25 grams of potassium chlorate decompose. Okay, first things first, chlorate, that means I've got this one here, okay, and that's my known, so I have a mass of that. I'm going to put that here because I don't have space underneath. Okay, so my mass is 25 grams of potassium chlorate. Okay, and I want to find the mass of potassium chloride. Okay, we have a mass, we have a formula, which means that we must be able to find our molar mass. Okay, so we're going to have N is equal to M on MR. So we've got 25 grams, and then potassium chlorate, you're going to take the 19 for potassium. So you're going to have 19 potassium and then 35.5, so 19 plus 35.5 plus 3 times 16. Okay, and that should give you a total of 122.55 grams per mole. Okay, so if we've got 22.55 grams per mole, that means if we do our final calculation, we're going to have a fairly reasonable number. So 25 divided by 122.55 is equal to 0.203 20, let's make that 4 with our rounding. Okay, so with this, it is important to remember when you're doing calculations to keep the non-rounded version in your calculator, but write your rounded versions down. So that's 0.204 mole. Okay, so that's of, let's put it in here, this is N of KClO3. Okay, I said I was going to show you a different way to do this. So this is the grid way that I've showed you a couple of times in class. So to work out my mole ratio, I'm going to take my KClO3, right, it as a ratio to KCl. Okay, I'm going to write my coefficient, which is 2, and my coefficient of KCl, which is 2. Okay, and then I'm going to put in my number of mole of the one that I know, 0.204, and then use X for the one that I'm looking for. Okay, this is set up as a ratio, so I can just cross multiply write it now as 2x is equal to 2 times 0.204. So x is equal to, when the 2's cancel each other out, it's going to be equal to 0.204, which makes sense because it's a 2:2 ratio, which is the same as a 1:1. Okay, so the n of KCl, which is what I was looking for, is equal to 2 times n of KClO3, which is going to be 2 times 0.204. So it's going to be 0.408 mole. Okay, so that is asking us how many grams though. So remembering I go from mole to grams by using my mass is equal to N times mR. This time N is 0.408, and then our molar mass is now for our potassium chloride. Okay, so now we're going to be looking at potassium chloride molar mass. Okay, so that is going to be our 19 plus our 35.5, which is going to be times 74.55. So we're going to take our 0.408, multiply it by 74.55. And we're going to get an answer of 30.41 grams. Okay, so what this is saying is that for 25 grams of potassium chlorate, we will generate 30.41 grams of potassium chloride. Okay, and we can use this one. The other way would have been to multiply by what we want over what we know, which would have been 2/2, which is equal to 1/1. So we would have ended up with the same answer. It doesn't matter if you can see the maths in this and do it a different way, as long as you are showing your ratio in some way. So like this, or like this in your working out, you're going to get the marks that are available to you. Okay, it doesn't matter which way you go, just pick the maths that makes the most sense to you and the way you work. Okay, I'm going to do a couple more examples. If you're feeling confident with this, I just remind you, you don't have to watch this whole video. Try the examples on your own and then just come back to see if you've got the right answer. Okay, so feel free to turn this off and go do your own work in terms of practicing. Okay, so here we are with me doing question number 3. Hopefully most of you are feeling pretty confident about this by now, but let's have a look. The 2 more questions, this one and one more. So how many grams of silver chloride are produced from 5 grams of silver nitrate? So we can see from our reaction here that we have silver nitrate reacting with barium chloride and then producing silver chloride and barium nitrate. So remember, hopefully you can remember, the first thing we're going to do is find each of our knowns. In this case, our known is silver nitrate. So we've got 5 grams of silver nitrate, and we want to find the grams of silver chloride. So N is equal to M on MR, which is going to equal 5 divided by 143.32 in this case. So if we take that 5 divided by 143.32, we get 0.0349 mole. Okay, and that is N of AgNO3. Okay, now I'm going to use the watt, just looking at this here. So if I'm going to multiply by 2/2, so they're both 2. So it's a 1:1 ratio. So my N of AgCl is going to be equal to my N of AgNO3, which is 0.0349 mole. So now I want to find my mass of AgCl. I'm going to use my mass is equal to N times Mr, 0.0349 substituting in, and the molar mass of silver chloride. I think we had this before. Whoops, I've used the molar mass of silver chloride in my calculation. So we need to go back and change that. So it will be the molar mass of silver nitrate. Sorry for that. Okay, is 169.87. That looks a bit better. Okay, so I'm just going to go back, and so we've used the wrong one. Oops, my pen's not working anymore. Okay, so we've used the wrong one. We should have used 169.87. Okay, so that should be, here we go, that's better. Okay, 169.87, which will change our calculations a little bit. So we've got 5 divided by 169.87. This is actually 0.0294. Okay, 0.0294 mole. Okay, so it's still the same ratio though, so 0.0294. And then we're going to change it up here. Okay, and we're going to multiply that by 143.32. So change that to 4.218 grams of silver chloride. Sorry about that, but it's always good to check your work. And you can see that we all make errors, so make sure if you show you're working, you can find those areas a lot easier. So hopefully you got the right answer and didn't make mistakes like I did. Okay, let's look at the next and the last question. Okay, so it's asking us now how many grams of barium chloride is necessary to react with the silver nitrate from over here. So now we're looking for this one. Okay, so we've still got 2AgNO3 is reacting with BaCl2 to give us 2AgCl plus BaNO3 too. Okay, so we've still got this situation. Now we've been told that we have 7.5 grams of silver nitrate, and we want to find out how much BaCl2. And you may be going, hang on, that's a reactant, not a product. But we can use this method to find out how much reactant is required to react with something, or how much product will be formed. It doesn't matter where it is in our equation, we can use the same process to find it. So N of AgNO3 is going to equal 7.5 divided by 169.87. Okay, don't go through calculating things more than you have to. We worked this out before, so we can just pull it from the previous question, and we will get 0.0441. Okay, mole. And so that's our number of mole. Remember that in order to figure out from one to the other, we need to use a mole ratio. I'm going to use my, this time, what I want is 1. What I know is 2. So N of BaCl2, which is what I want, is going to equal to 1 over 2 times N of AgNO3. So that's a half of 0.441. Okay, so that is 0.220 mole of barium chloride will be required. Again, it is asking us for how many grams. So we're going to need to work out our molar mass. So mass of barium chloride is going to be equal to the molar mass of barium plus 2 lots the molar mass of chlorine, which when we add all that up, okay, remember to include the adding up of your molar masses in your working out. I'm not, but you should. That way we can see if you've made an error. So we're going to have our mole, which is 0.220, multiplied by 208.23, which is the molar mass of barium chloride. And that is going to give us, sorry, that keeps swapping, 208.23 is going to give us 4.597 grams of barium chloride. So we need 4.597 grams of barium chloride to react with 7.5 grams of silver nitrate, and that will produce 4.218 grams of sodium chloride. Okay, so hopefully that is making some sense. Remember, you can come back to these at any time. This video is super long because we've gone through a number of examples, but remember, essentially what you want to do is practice, 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 practice. Go to chapter 1 in your textbook. You can do now up until mass stoichiometry, and also have a go at doing all the questions on worksheet 5.1. They're mass calculations. The answers will be up on Schoology. Okay, don't move on to limiting and excess until you've got this sorted. Okay, because you can't do limiting and excess without understanding your mass. Good luck. Remember to email me any questions if you get stuck, or post them up onto Schoology, and that way I can put up some solutions for everybody. Okay, and good luck with doing your calculations.